The problem you see here is a very typical regression type problem. You're going to be given data. In this case, we're given years and concentration of carbon monoxide in the air. And we're going to be asked several things. Graph the data, computer regression, graph the data and the regression, use the regression to make some estimates, and then some general questions. To do all this work takes quite a bit of time. The first thing you should do is go into your calculator and turn the diagnostic on. What does that do? Well, we'll talk about that as we go. To turn the diagnostic on, go second. Oops, got to turn my calculator on here. Second, catalog. And then diagnostic on would be under D, so push the alpha and then this X inverse button to get down to D. And scroll down to where you see diagnostic on, hit enter again. Now once you do that, you'll never have to do it again. And we'll talk about what that does in a second. Now the first thing we need to do is we need to input all of this data into the calculator. To do that, we go into our list. So we push Stat, Edit. And it tells us use 7 for 1987, 8 for 1988, so on and so forth. So we go 7, enter, 8, enter, 9, 10, 11, 12, and 13. And then we move over to L2, and we type in all these numbers, 6.69, 6.38, 6.34, 5.87, 5.55, 5.18, and finally 4.88. So there's all our data typed in. First thing it asks us to do is graph the data. To do that, we need to go into this menu here, which is the statistical plotting menu. So we go second, and then the stat plot. And we're going to hit enter to turn it on. So we're going to hit enter again. This is what we want. This is called a scatter plot here. It will graph the data. Our X's are in L1. Our Y's are in L2. We can use a little box, a little plus sign, or a little dot. Personally, I like the little box. Go to Y equals. Make sure you don't have anything typed in there. So we get rid of that. And finally, go zoom. Scroll down to number 9, zoom statistics. And it will graph the data in a fairly good window. Now what you should see about this data is that it is quite linear. This one dot looks like it's out of line a little bit, but the rest of them are in a line. What they're asking us to do here in this problem is compute a linear regression for this data. So find the line that matches quite well. The way to do that is to go back into the Stat menu, go over to Calculate, come down to Linear Regression. Now notice there are other types of regressions. We'll use these later on in the course. We're going to use linear. Then what you need to do is tell it where the X numbers are. Second, number 1 to get L1, comma, second, L2 to get Y2 for the Y2 numbers, comma, then push this VARS button, go over to Y variables, function, Y1, enter. Now the calculator has done a couple of things here. One, it's computed the regression. So over here in my homework I would write Y equals negative 0.31x plus 8.92. The other thing it's done is it's computed this R squared thing. This is the reason we turn the diagnostic on. This R squared being 0.98 tells us that the graph and of this line we just computed and the data are going to be very close. This isn't exactly true, but roughly what you can think of is that the line is going to be 98% correct. And let's take a graph, and you can see that the line and the data do match up quite well. And that's what we saw from that 0.98 on the R squared value. Now, use a regression to estimate the concentration of carbon monoxide was in 1994. So basically what we want to do is we want to plug in the number 14. Probably the easiest way to do that is to go to the table. You could scroll down, plug in the number 14, you get 4.61. How confident am I about my answer? I'm very confident because my r squared value was 0.98, which tells me my line was 98% accurate, and x equals 14 is very close to all the data that we had, the data we were given. We're not very far away from the data range. Finally, not finally yet, but question D. Put that answer in the wrong spot there. Use your regression to estimate the year in which the carbon monoxide will be 1.32. To do that, go to the y equals screen, type in 1.32. Notice that our regression equation was automatically typed in for us. That's always a handy thing. And what happens is we don't see that line that we typed in because of our window. Let's change our window, make our y-min go down to 0 here. And what we're going to look for is where this line crosses the horizontal line. Still can't see it. Need to make our x's a little bigger here. Let's go up to 25 maybe. And finally, we can see that these two lines are going to cross, so we can calculate the intersect. So it says it's going to be 24.6 years. Let's call that 25 years. That's 25 years after 1987, so that's the year 2005. How confident are you of your answer? Not real confident this time. Primarily because this data is not close to the answer we got. Too many things can happen when you get that far away from your data. Things can change dramatically. This is an estimate, but I would not be terribly confident of it. Finally, what is the slope of this model? The slope is given here in our equation, negative 0.31. Interpret that slope in the context of this problem. In the context of this problem, remember slope has y2 minus y1 over x2 minus x1. So this is the decrease in parts per million of carbon dioxide per year. It's the y values divided by the x values.